Hey guys, welcome back to chapter 14. We're going to work another weak acid equilibrium problem. So here's our problem. Find the hydronium concentration and pH of a 0.2 molar NO2 solution where the Ka is 4.6 times 10 to the negative 4. Go ahead and pause the video, try to get as far into this as you can, and I'll catch up with you on the other side. All right, so first things first here, let's draw a balanced chemical equation. So we've got HNO2. Remember, we first have to identify this as strong or weak. Of course, on a test, it won't have the label at the top saying it's a weak acid. So just as a reminder, if it's not one of the big five, then it will be weak. The big five: hydrochloric, hydrobromic, hydroiodic, nitric, and sulfuric. Nitric acid is HNO3, so close. This is HNO2, so nitrous. It's a weak acid. So we're going to write the balanced equation, HNO2 plus water. It is a weak acid, so it's going to be a double-sided arrow. And then our products, HNO2 is our acid, so it's our proton donor. So NO2 will be left. And then in this case, water is our base. It's going to accept that proton and become hydronium. Next step here is we're going to need an ice table. And remember, we fill that ice table out with X's. So we've got I, C, E. We put our reactant, HNO2. We do not include water because water is a liquid. And then we do our products, NO2 and H3O. So filling in what we know our weak acid is 0.2 molar. There is no mention of the products, so we always assume that's 0 and 0. That's it. That's all we have. So we need to fill in the table with our hypothetical X's. The only direction for our products to go is up, which means our reactant will have to go down. And then at equilibrium, we'll have 0.2 minus X, X, and X. Next step here is we're going to use our K equation, and we're going to solve for hydronium. So remember, that's kind of the purpose of this exercise, is to solve for the hydronium concentration at equilibrium. Once we have hydronium concentration, we can then get to pH. So our Ka is going to be products over reactants. Products are always on the right-hand side, so NO2, hydronium, and reactants are always on the left-hand side of the arrow. And we do not include water because it's a liquid. Now we plug in what we know. So we know Ka is 4.6 times 10 to the negative 4th. At equilibrium, our reactants are X and X. At equilibrium, our product is 0.2 minus X. I'm going to click ahead a slide just so I have some more room to work here. 3 slides. All right, so here's where we're at. We are at 4.6 times 10 the negative 4th equals X, X, 0.2 minus X. So in this chapter, again, we can make the assumption that X is small will work. So we get rid of any X's that are being added or subtracted. So that's going to leave us with 4.6 times 10 to the negative fourth. On top, I can reduce this to x squared, and what's left on the bottom is just 0.2. Now to solve for x, I'm first going to get rid of that denominator. So I'm going to multiply by 0.2. Whatever I do to the right side, I also have to do to the left side, so multiply by 0.2. So that's going to leave me with x squared on the right, and then I've got 0.2 times 4.6 times 10 to the negative fourth, and we get 9.2 times 10 to the negative fifth. And then to solve for x, we're going to take square root. So we are going to have x equals second square root, second answer, 0.0096 equals x. And then remember, what is x? What does that even mean to us? So x is the concentration of hydronium at equilibrium. So that was the whole purpose of solving for x. So we have that hydronium concentration. So up here, the hydronium concentration is 0.0096 molar. We can then use this information to solve for pH. So pH is the negative log of that hydronium concentration. So negative log of 0.0096. So pH equals negative log 0.0096. And we get 2.02. So that is just another example of how to solve for a weak acid. So we create an ice table, fill our ice table in with x's, solve for the concentration of hydronium at equilibrium, and then use that value to solve for pH. I hope you guys found this helpful.